Good day, Math Buddies! Sir Robin here, your math instructor. For today's video, we will be solving roots of quadratic equation by completing the square. Of course, we will be guided with this objective, and that is to solve roots or solutions of quadratic equation by completing the square. To start, let's bear in mind this concept. Roots or solutions of quadratic equation that cannot be solved by extracting square roots or factoring can be obtained by completing the square. And these are the steps in solving for the roots of quadratic equation by completing the square. First, divide both sides of the equation by a, then simplify. Second, write the equation such that the terms with variables are on the left side of the equation and the constant term is on the right side. Third, add the square of 1/2 of the coefficient x on both sides of the resulting equation. Please take note of this one. The left side of the equation becomes a perfect square trinomial. Fourth step, express the perfect square trinomial on the left side of the equation as a square of a binomial. Next, solve the resulting quadratic equation by extracting square root. And to obtain the solutions or roots, solve the resulting linear equation. With this, let us apply these steps in our first example. Determine the solutions or roots of x squared plus 7x plus 10 equals 0 by completing the square. For our solution, given the equation x squared plus 7x plus 10 equals 0. First, make sure that the value of a is equal to 1. In this case, we will skip step 1. All we need to do next is to transpose positive 10 to the right side of our equation, as we write terms with variables on the left side of the equation and constant term on the right side. Using subtraction property of equality, we will eliminate 10 on the left side and transpose it to the right side of our equation. We obtain the equation x squared plus 7x equals negative 10. Then, we will add on both sides of the equation the square of the half of coefficient x. In this certain example, x has a coefficient of 7. Here, we will get half of 7, square it, and add this on both sides of our equation, making our left side of the equation x squared plus 7x plus 49 over 4 a perfect square trinomial. Next step states, express the perfect square trinomial into a square of a binomial. This means x squared plus 7x plus 49 over 4 can be written as quantity x plus 7/2 squared. And that is equal to the simplified form of negative 10 plus 49 over 4, which is negative 40 plus 49 all over 4. Then let's simplify our fraction on the right side of our equation. That is 9/4. Then, we will apply extracting square roots in order for us to get rid of the exponent 2 on the left side of our equation. Because rules in radicals state, if the index and exponent is the same, we can cancel it out. The simplified form becomes x plus 7/2 is equal to positive negative 3/2. Then, we will get rid of 7/2 on the left side of our equation using subtraction property of equality. So, we will eliminate it on the left side and move it to the right side of our equation. This leads us to x is equal to positive negative 3/2 minus 7/2. After this, we need to separate positive and negative 3/2 into two possible linear equations. This leads us to x is equal to 3/2 minus 7/2 and x is equal to negative 3/2 minus 7/2. Let's simplify our first linear equation. X is equal to 3/2 minus 7/2 is equal to negative 4/2, and it can be simplified as negative 2. On the other hand, our second linear equation, x is equal to negative 3/2 minus 7/2, can be written as negative 10/2 and can be simplified as negative 5. This means the solutions of x squared plus 7x plus 10 equals 0 are negative 2 and negative 5. Let's have our next example. Determine the solutions or roots of 2x squared minus 16x plus 30 equals 0 by completing the square. For our solution, given the equation 2x squared minus 16x plus 30 equals 0. If we noticed, the coefficient of our x squared is 2. In this case, we will apply first step in solving for the roots, and that is, we will divide both sides of the equation by a, and in this case, it is 2. As we divide this equation by 2, the simplified equation becomes x squared minus 8x plus 15 equals 0. Then, we will write terms with variables on the left side of the equation and constant term on the right side. This means 15 will be transposed to the right side of our equation using subtraction property of equality. So we will eliminate it on the left side and move it to the right side of our equation. Then, we will add both sides of the equation the square of the half of coefficient x. In this certain example, the coefficient of our x is negative 8. Half of negative 8 is negative 4. Squaring 4, that is 16. This means 16 will be added on both sides of our equation, making x squared minus 8x plus 16 a perfect square trinomial. Let's express this as a square of a binomial as we write quantity x minus 4 squared equals 1. It is a result when we combine negative 15 and positive 16. After this, we will apply extracting square roots in order for us to eliminate the exponent in our square of a binomial. The simplified equation becomes x minus 4 is equal to positive negative 1. Then, we will transpose negative 4 to the right side of our equation using addition property of equality. This leads us to x is equal to positive negative 1 plus 4. Here, we need to separate positive and negative 1 into two possible linear equations. This leads us to x is equal to 1 plus 4 and x is equal to negative 1 plus 4. Simplifying 1 plus 4, the sum is 5. And simplifying negative 1 and 4, the result is 3. This means the solutions of 2x squared minus 16x plus 30 equals 0 are 5 and 3. Another example. Let's determine the solutions or roots of 3x squared minus 36x plus 60 equals 0 by completing the square. For our solution, given the equation 3x squared minus 36x plus 60 equals 0, we will divide both sides of the equation by 3. The simplified equation becomes x squared minus 12x plus 20 equals 0. Then, we will write terms with variables on the left side of the equation and constant term on the right side. This means 20 will be transposed to the right side of our equation using subtraction property of equality. We will eliminate 20 on the left side and transpose it to the right side of our equation. It leads us to x squared minus 12x equals negative 20. Then, we will add both sides of the equation the square of the half of coefficient x. In this certain example, our x has a numerical coefficient of negative 12. So, half of negative 12, it's negative 6. Squaring it, that is 36. And it will be added on the left and right side of our equation, making x squared minus 12x plus 36 a perfect square trinomial. Then, let's express this into a square of a binomial. This becomes quantity x minus 6 squared equals 16. Then, we will apply extracting square roots as we eliminate exponent 2 on the left side of our equation. And this leads us to x minus 6 equals positive negative 4. Then, we will get rid of negative 6 on the left side of our equation and transpose it to the right side using addition property of equality. Then, the simplified equation becomes x is equal to positive negative 4 plus 6. So, we need to separate positive and negative 4 using two possible linear equations. And these are x is equal to 4 plus 6 and x is equal to negative 4 plus 6. To simplify, the left side of our equation 4 plus 6, the sum is 10. And to simplify negative 4 and 6, the result is 2. This means 3x squared minus 36x plus 60 equals 0 has solutions 10 and 2. Let's have the fourth one. Determine the solutions or roots of x squared minus 16x plus 12 equals 0 by completing the square. In this example, the given equation is x squared minus 16x plus 12 equals 0. And our x squared has a numerical coefficient of 1. So we will skip step 1 and proceed to step 2 as we transpose 12 on the right side of our equation as we write terms with variables on the left side and constant term on the right side. Using subtraction property of equality, we move 12 on the right side of our equation. Then we will add both sides of the equation by the square of half of coefficient x. Here, x has a numerical coefficient of negative 16. Half of negative 16 is negative 8, and squaring negative 8, that is positive 64. 64 will be added on both sides of our equation, making x squared minus 16x a perfect square trinomial. Let us express this into a square of a binomial, making x squared minus 16x plus 64 equal to quantity x minus 8 squared equals 52. Then, let's apply extracting square roots. In this certain equation, here, square root of 52 is not a perfect square. So we need to simplify this radical as we look for factors of 52 where one is a perfect square and the other is a non-perfect square. In this case, 52 has factors 4 and 13. Here, 4 is a perfect square and 13 is a non-perfect square. So here, square root of 4 is positive negative 2 and we will copy the radical square root of 13. This means square root of 52 can be written as positive negative 2 square root of 13. Then, we will transpose negative a to the right side of our equation using addition property of equality. We will eliminate it on the left side and the simplified equation becomes x is equal to positive negative 2 square root of 13 plus 8, or it can be written as x is equal to 8 plus and minus 2 square root of 13. This means the solution of x squared minus 16x plus 12 equals 0 would be 8 plus and minus 2 square root of 13. Let's have another example. Determine the solutions or roots of x squared minus 9x plus 5 equals 0 by completing the square. In this example, the equation is x squared minus 9x plus 5 equals 0. In obtaining for the solutions or roots of a quadratic equation by completing the square, make sure that our a is equal to 1. In this certain equation, x squared has a numerical coefficient of 1. Here, we will skip step 1 and proceed to step 2 as we write terms with variables on the left side of the equation and constant term on the right side. This means 5 will be moved to the right side of our equation using subtraction property of equality. This eliminates 5 on the left side and the simplified equation becomes x squared minus 9x equals negative 5. Then, we will add both sides of the equation the square of the half of coefficient x. Here, x has a numerical coefficient of negative 9. So we will get half of negative 9, and that is negative 9 halves. Squaring it, that is 81 over 4, and it will be added on both sides of our equation. X squared minus 9x plus 81 over 4 is a perfect square trinomial, and we can express this into a square of a binomial, and that is equal to quantity x minus 9 halves squared. Likewise, let's also simplify negative 5 plus 81 over 4, and it is equal to negative 20 plus 81 over 4, or can be written as 61 over 4. Then, we will apply extracting square roots as we eliminate exponent 2 on the left side of our equation, leading us to x minus 9 halves equals square root of 61 over 4. Then, let's simplify. X minus 9 halves is equal to positive negative square root of 61 all over 2. Here, 61 is not a perfect square and it doesn't have factors where one is a perfect square and the other is a non-perfect square. On the other hand, 4 is a perfect square and square root of 4 is equal to 2. Then, we will get rid of negative 9 halves on the left side of our equation using addition property of equality. This leads us to x is equal to positive negative square root of 61 over 2 plus 9 halves. And can be written as x is equal to 9 halves plus and minus square root of 61 over 2, or x is equal to 9 plus and minus square root of 61 all over 2. This means the solutions or roots of x squared minus 9x plus 5 equals 0 would be 9 plus and minus square root of 61 all over 2. Let's have another example. Let's determine the solutions or roots of x squared minus 4x plus 15 equals 0 by completing the square. The equation given is x squared minus 4x plus 15 equals 0, where a is equal to 1. So we will need to write the terms with variables on the left side of our equation and constant on the right side. So using subtraction property of equality, we will subtract both sides by 15 to eliminate 15 on the left side of our equation. This leads us to x squared minus 4x equals negative 15. Then we will make the left side of our equation a perfect square trinomial as we get half of coefficient x and square it. So half of negative 4 is negative 2. Squaring it, that is 4. So 4 will be added on both sides of the equation, making the left side a perfect square trinomial. So x squared minus 4x plus 4 can be written as a square of a binomial, and that is equal to quantity x minus 2 squared equals negative 11. Then, apply extracting square roots as we eliminate the exponent 2 on the left side of our equation. But if we will notice, the right side has an expression square root of negative 11. Here, our radicand is a negative number. And bear in our mind that there is no number multiplied to itself will lead us to a negative result. In this case, we will stop our solution here and state our conclusion directly, which says, therefore, the equation x squared minus 4x plus 15 equals 0 has no real solutions or roots. This time, it is your turn. Solve the roots of the following quadratic equation by completing the square. First, x squared plus 6x minus 16 equals 0. Second, x squared minus 3x minus 28 equals 0. And third, 2x squared plus 10x plus 8 equals 0. There you have it. Hope you learned something new today. God bless us all.